talk to me about the rise of vector databases.
In 2023, we saw this huge movement or rise in the popularity of these vector databases. And this was really brought about because of the popularity and the proliferation of large language models and the services people build on top of them, like ChatGPT or Google's Bard. And what these vector databases allow you to do is essentially store embeddings of data. And these embeddings are these single dimension vectors of these floating point numbers that are generated when you convert data or send data into a transformer, something like BERT or ChatGPT and others have their own thing. And it's a way to encode the contents or semantics of what's in data. And so these vector databases allow you to take those embeddings, store them in the database, and then they build indexes on top of them that allow you to do nearest neighbor search very, very efficiently, as opposed to like having to do a brute force scan across all of the vectors. So these vector databases are really designed to do this additional search properties. And so, although there was sort of a downturn in the funding from the venture capitalists in the database space, the big exception was, of course, vector databases. A lot of the bigger companies all raised some pretty serious rounds in 2023. So, at their core, in my opinion, a vector database is essentially a document database system where people can store like a JSON record with additional support for these vector indexes. And the interesting that came about in 2023 was that all of the sort of existing, general purpose database systems like the Postgres's, the Mongos, like things that aren't really sort of defined for doing vector search, they all announced support for vector indexes in 2023. And it took a really short amount of time, which was surprising to me. And the big question that I have that I talk about in the blog article was that it's not clear to me whether all these systems added vector support so quickly because AI or these large language models is such a compelling use case where everyone's asking for it. It was a huge deal, and therefore they had to add something very, very quickly. Or is it also because the engineering effort to add a new index data type to support vector search or nearest neighbor search the way that the vector databases guys do, that's not a huge ask, a huge lift into the system. And so I actually think it's a combination of the two. I think the large language model stuff is super important. It's going to be obviously a major step forward in computing. But I also think adding a new index type to an existing database system is not a major ask. Now, there's some challenges you have to do to deal with how to expose information or metadata about what the index can do, or the selectivity of doing lookups to the rest of the system. But like it's not like they had to throw everything away and start from scratch. So I think what will happen in 2024 over the next 12, 24 months is that I think that the hype of vector search will die down a bit. And vector search will just be, and vector indexes will just be another sort of expected to have or table stake capability of a database system. Sort of the way logging recovery is sort of considered, any new system would have to have it. So I think it's just going to sort of end up being like that. And that if you really need high performance vector search for some applications where it's necessary, then you'd want to use a specialized vector database.
Cool. I think, we already did the other video on what is a vector and pros and cons. I think we're pretty well covered. So the next bucket is, I believe it's SQL 2023 standard, right? There were kind of two big updates you talked about, right? There's property graph queries and multi-dimensional arrays.
Yeah, so let's take each of these one by one. So in 2023, there was the new update to the SQL standard. This is the international standard, so it's a consortium and a board of people that are from various companies and academics that are in charge of defining what the SQL spec is going to be going forward. And there's always updates to deal with frustrations or rough corners around SQL. But the big two new additions though were SQL PGQ, property graph queries, and SQL MDA, multidimensional arrays. So the property graph query support is sort of inspired by work that had been done before with Oracle, Neo4j, and TigerGraph GQL. And it's part of this, it shares some of the lineage of coming from another separate standard called GQL, which is for just doing queries on graph databases. And what this allows you to do is you can now define a graph structure and relationship between entities or records within your database system, within your database, and then do path traversal queries on top of that. So the reason why this matters is that oftentimes people want to model their database or the information that they're trying to represent in the database using graphs. And there's inherently, there's times where you actually, simply makes sense to do this. Like if you have like a social network, you have friends or people you like, right? Those are relationships you want to capture. And then you want to be able to do path traversal to extract new information about this graph data. And so prior to SQL PGQ, to do graph traversal in pure SQL was awkward or cumbersome and oftentimes not easy to do. Just because the nature of SQL is really, trying to do operations, do lookups on bags or sets of data and not have this path traversal aspect. You can kind of get away with it with common table expressions, but it's not easy to do. And so what people have tried to do is build sort of veneers or translation services in front of SQL that allows you to have a sort of graph-centric API query language that then gets converted to SQL. And then even if there's multiple queries, that's still running on the server side. Right? Because if you have to do graph traversal, the worst way to do it would be your application sends a query, gets information about a node, follows an edge, that gets sent back to the application, and then you do another query to follow that edge. And so what the graph databases can do better than sort of SQL before PGQ was single API commands or single requests that do that traversal all on the server side. So with these middleware approaches, things are still processing on the server side, but there's still maybe multiple SQL queries. Now with PGQ, you can do this all within one query. And now the database understands the semantics of what the relationships between objects in your database, and it can build indexes or auxiliary data structures to accelerate those queries. So as of right now, as far as I know, in 2024, Oracle version 23 is the only, popular or widespread relational database system that supports PGQ. And this makes sense because Oracle is part of the standards body that put that together. There's a forked version of DuckDB that's experimental from researchers at CWI, but that's I don't know whether that's going to end up in DuckDB or not. But I suspect in the future, I think that there's enough of a compelling use case here that people would want to have PGQ and use that in applications. So all the other major commercial vendors relational databases will eventually support it. With SQL and MDA, this is a bit of a nuanced extension to SQL. Like SQL PGQ is a major update. SQL MDA, it's adding support for like what we'll call true multidimensional arrays in SQL. So SQL has had arrays since SQL 99. They then expanded it to do nested arrays in I think 2023. But with the 2003, the 2023 version allows you to have true multidimensional arrays of arbitrary dimensions. So the reason why this matters is that oftentimes people want to interact with data that's in arrays or matrices, but they can't easily do it in SQL. So what you oftentimes see is people do just select queries to extract all the data out of a relational database, put it into like a CSV or Parquet file or data frames, and then just do all the processing they want to do locally inside, in Pandas or a Python notebook. And now with MDA, if your database system supports this, you can do a lot of the operations you would normally could only do in Python, you can now do this directly in the database system. So the spec has been out since 2019, and then I think it got included in the larger roll-up of the major release of the new standard in 2023. As of so far, the only database system that is that supports this is Rastaman, which is a European array database that's been around since the 90s. This one, I suspect, will not get picked up as quickly as the PGQ extension. And I think because oftentimes the people that need like these large multi-dimensional arrays and the way that Rastaman is supporting is the scientific community. And they oftentimes, they use other things than database systems. They use HDF5. They have, the science people have their own, HPC people have their own sort of set of tools, and they don't always use relational database systems.
Gotcha. I guess, does this all, like between the vector stuff and then the updates to the SQL standards, does it kind of fit into your predictions over the years of, SQL isn't dying anytime soon, relational databases are here to stay? I mean, obviously, there are always going to be specialized use cases for these niches, right? But,
yes. Yeah. So I mean, if you look at the PGQ MDS stuff, like that's just, again, SQL expanding its capabilities to handle whatever the new application problem space that maybe didn't exist a few years ago. What's interesting about for both of these things is that the graph queries and the multidimensional arrays is that they go against the original ideas of Ted Codd's relational model from like 1969, 1970, right? And his original ideas were that the values had to be scalar, like so you can no arrays, no nesting structures, and no explicit relationships between, like if you were to define relationships between relations or tuples or records, you would do this through like foreign keys, not this sort of property graph sort of infrastructure built on top of it. So again, is the relational model has expanded and accommodated new capabilities over time, and I don't see that anytime soon. So, in 10 years from now, there'll be some other extension. Actually, I probably suspect in 10 years from now, we'll see vector search extensions in SQL. The problem with that one, by the time it gets 10 years from now, everyone will have implemented their own version or dialect of it for the syntax of how to do vector lookups or nearest neighbor lookups in SQL. And so the standard will be there, but nobody's actually going to support it exactly as it's defined. Whereas in PGQ, because nobody supports it now, and the spec got out first, it may be the case that we might be in a shape where a bunch of systems end up going to support the same syntax for these things. JSON's another good example. JSON came out in a bunch of systems, like Postgres was 2012, Oracle, MySQL roughly around the same time, but the SQL standard didn't have it until 2016. And by then, all the systems basically had their own different quirks or nuances of the language in SQL, how they interact with JSON data.
Cool. So I don't know if the next section has the most drama. Maybe it's the VC funding. I guess it's MariaDB. You think that's where most of the biggest amount of drama laid this year?
Yeah, I mean, again, it's not a good sign when you're a company and your product is this open source database system and you're selling services or hosting of it, and then there's this separate well-known foundation that's in charge of most of the development, and the nonprofit foundation says, "Hey, you guys are a dumpster fire, a hot mess." Then that's not a good sign. Yeah, and so I would think I'm not privy to all the discussions that happened at MariaDB, why they decided to go IPO using the SPAC. If we look at something like Mongo, you look at something like Snowflake, Couchbase, Elastic, they all went through the expected path towards becoming a public company. I'm not aware of any other database startup that has gone the SPAC route other than MariaDB. And again, I'm not privy to the financial discussions of what motivated that, or whether that was shady or not. But to me, it smells funny. And when you look at what they've had to do between the layoffs, killing off products that they've recently acquired, it's hard to see it's hard to see how they continue being justified as a public company.
Yeah, I mean, I guess I know you kind of already talked about it just now and in the blog, but I mean, like, what's your outlook? Because I know from the AutoTune standpoint, we continually get people that are like, hey, do you support GCP or Oracle or this? I think we have had one in the last year ask for MariaDB. So, kind of what is the outlook besides the drama there?
So the background history, which I didn't have time to get into the blog article, was I talked about a little bit. Was MySQL was a separate company, and then they got acquired by Sun, and then for MySQL, there was this other storage manager called InnoDB, which is the default now. That was a separate company from the MySQL AB company, and then Oracle bought InnoBase. They bought the people that made InnoDB. So you had this weird setup where like MySQL was owned by Sun, and they didn't have a good storage manager. They had MyISAM, but it was primitive. It had a bunch of problems. And then there was the better storage manager, InnoDB, but that was owned by Oracle, right? But that seemed to be okay for a while. But then Oracle buys Sun, and now they own the entire, all the pieces you would need to run MySQL. They own the MySQL piece, and they own the InnoDB piece. And so that was what, 2000, I think 2010 or something, or 2009. And at the time, a bunch of people freaked out because they thought that Oracle was going to basically kill off MySQL, was going to sort of mess around with the governance of the open source project. And I remember at the time in 2009, when it was announced, there was a bunch of attempts to fork MySQL and have it be independent from Oracle. And so MariaDB obviously was done by Monty, who was the founder of MySQL. There was another project called, I think, Drizzle, that was going to be sort of a fork of it, and it was going to be the open source community version of it. That didn't go anywhere. I think there might have been one or two others at the same time. So there was all this fear in 2009 that, oh my God, Oracle's going to kill MySQL. Flash forward to 2023, 2024, Oracle, in my opinion, has been pretty good about it. And it's still open source. They're still making improvements to it, maybe not to the extent that Postgres is, because Postgres, the community has sort of solidified around that, and everyone's putting a lot of effort in making that better. But from as far as I know, there's not been any major scandals with Oracle owning MySQL. But now, MariaDB was fork of MySQL to avoid any issues with Oracle, but now they're the ones that are having much issues because of the corporation. So to me, that's somewhat ironic. I think that it's not going to matter too much. Because the default choice for everyone now is Postgres. And long term, is MySQL going to fade away? No, it's very hard to kill off databases, right? And MySQL is certainly still widely used everywhere. But I think that over time, the significance of it and the need to have a fork like MariaDB will get diminished because all the energy is going to be put into Postgres.
Gotcha. So let's talk about, again, more drama. I think this was January of 23. Complete grounding, FAA outage. What the heck happened there?
Yeah, so I was actually flying back from CIDR, from the database conference in Europe, and I remember as coming down into Newark, the plane flies sort of low enough where you actually can get cell phone reception as before you land. And I remember just seeing all the alerts oh, the FAA is grounding all the planes. And they didn't announce anything on the plane when I was on, but then once we landed, you realize, oh yeah, all domestic flights in the US are shut down. So the FAA maintains this system called NOTAM, the notice to air missions, and this is basically like an update service to announce changes to pilots before and after while they're flying of any hazards or anomalies or unexpected things on their flight path. Like, is it going to be heavy wind, or is an airport all of a sudden under construction, or there's been problem and it get diverted somewhere else. And so they had a major outage of this thing, and so they had to stop all flights because the pilots aren't going to know what's ahead of them. So it turns out, I think either the same day or in a few days later, that the reason why the service crashed is because the database crashed. And the reason why the database crashed is that some contractor tried to load in a file. That file was corrupted, and then they tried to load in a backup, and the backup was corrupted too. So they had to, I guess, bring back tapes or something, like an old archive, to get the system back up and running. And so when this crash occurred, I spent some time trying to figure out, okay, what's the database crash? That's clearly in my wheelhouse, the things I care about. What database were they using? And I spent a bunch of time trying to just do keyword searches of NOTAM Oracle, NOTAM Nonstop, like what databases would could have existed, could have been using, because the system was deployed in 1988. So there's this 35-year-old service that is super mission critical that we need to fly any plane. But then again, they're running on hardware or application software written from the 80s. That's not necessarily a bad thing, right? People run old systems all the time; they work just fine. And so, but I was just trying to understand what was the database that crashed. And after looking at PowerPoint slides from government websites, any job listings for the FAA on the NOTAM service, I saw no information about what the database actually was. And it turns out that somebody through a bunch of other blog articles or posts that after the crash for the next few months, it came up that they were running on this mainframe from Philips from 1980s that they don't make anymore. So you can't get parts for it. So when Philips discontinued it, the FAA bought all the spare parts in the US because they have to maintain the system. And because it wasn't running Unix, it doesn't really have an operating system. That means you can't run, you can't just get off the shelf software like you can now. You just run it on your laptop or your local machine. That means they had to write custom database software. And that's always a bad sign right there, because writing a database system is very hard. And writing a database system that needs to be fault tolerant and handle crashes and not ground planes is super, super hard. So to me, this is just a good example of why people shouldn't be writing, most people should not be writing their own database system software. They should not be maintaining data on just themselves or backup files, to do recovery and things like that. For the core database itself, you want to be using a database management system like a Postgres, like a MySQL, Oracle, whatever. And I'm not saying had the FAA used one of these products, the problem wouldn't, there'll be zero problems, because there's always, it's software, humans make mistakes, there's always going to be issues. But I just think that when you're using, a tried and tested software like a database management system, especially one that's widely used, these problems are less likely to occur.
Yeah, and I swear I saw a news story maybe in the last year, maybe it happened around the time the outage happened, or was looking back, reflecting on a story. But I swear it's outside the US, aviation flight traffic controllers are much different systems. Here in the US, they literally still use, in some airports, paper flight strips, and they'll move those around. So there seems to be still a lot of archaic technology and methodology going on.
This is a problem in tech where if it's not broken, fix it. I'm not saying that's a problem, but oftentimes the early adopters are stuck with legacy solutions just because no one wants to spend the time or energy to upgrade it. So we had this problem at the university. So Carnegie Mellon University was one of the first universities in the US, not only to be on the internet, that's why we own very large IP address blocks, but we also had one of the first wireless internet systems. And so that means they didn't upgrade it for a long, long time. and there was a bunch of issues over the years, and they finally just ripped everything out and reinstalled everything, and probably in the last 5 years or so. Because to that point, like we had it for a long time, nobody wanted to spend the time and energy to replace it, and then over time it just kept getting worse and worse and worse. So it's similar thing with the aspects of the FAA. You know, it's this big hunking mainframes that they're running for this thing, and no one wants to go and take the risk and say, let's rip it all out and rewrite it.
Yeah,
but now
for
they
sure.
have to.
Yeah, until something terrible happens, you have your kind of either black swan or quasi black swan event.
Yep.
Let's talk about database VC funding. There's a lot going on there. There's a lot of rounds. I mean, if you kind of had to zero in on a couple that you think are, probably worth highlighting, and what does it make you think of the landscape right now?
So I think the VC landscape is tight right now, not just for databases, across all tech and all industries. One exception would be anything related to ChatGPT or AI or LLMs. Those kind of companies seem to be getting funded. Still seem to be getting funded. For even I think developer focused tech or even enterprise tech, it's a much different landscape than it was 3 or 4 years ago. Really, since the blockchain Web3 stuff all sort of died out. I'm glad it died out, but then that sort of makes things hard for everyone else. I think that obviously, as we talked about before, there's a lot of money being thrown at the vector database stuff. That's sort of new and shiny. There is some funding still happening, but we're not seeing the big, huge rounds that we saw in 2022. So a lot of the major OLAP companies were receiving $250 million rounds, like for ClickHouse and so forth. I don't know whether that's going to come back in 2024. I would suspect maybe not. And that means that either these companies are going to have to push to become profitable sooner than they maybe would have wanted to do. And that could mean layoffs. It could mean other cost cutting efforts. You could try to do the SPAC approach to go IPO like MariaDB, but I think given that what the disaster that was, I don't think anybody's going to do that. And again, it's a questionable legitimacy, I think, the eyes of investors. The alternatives, a company could take a down round where they have to take more money with a lower valuation than they would have wanted or what they had before, or they could go, they could go get bought by private equity and hope that turns things around. So I don't think we'll see the contraction in the database marketplace in 2024 just yet. I probably think we have another year before that becomes more of an issue. And who knows, again, that the tech industry turns around and everybody's flushing cash and things are looking up and up, then we'll bypass that disaster. But I think that as a lot of companies who raise a lot of money, who are on the verge of going IPO, Databricks is the most obvious one. They'll get out first. But a bunch of these other ones, it's not clear to me what's going to happen and whether the market can sustain so many of them. But it's going to be this weird thing where they have a large enough user base, and if they sort of reorganize the engineering teams and cut down on costs, they could approach being profitable, and then that maybe sustain them for a bit longer. But if they can't do that, then I could see them getting bought, but not by the major tech companies like Amazon, Google, Microsoft, and others, ones like that. They would get bought by these IT service companies who then sort of just put the system into maintenance mode and milk the fees. But if it's cloud hosted software, then what's going to happen there? I don't know. 2025 is going to be interesting. I think 2024, everyone's sort of waiting to see what's going to happen in the tech field. But I think 2025 there'll have to be some hard decisions.
We've talked about the venture landscape and a lot of other companies, but what do you see on the roadmap for OtterTune in 2024?
Yes, with OtterTune, the big thing happened in 2023 was we're seeing more people asking us like, okay, like OtterTune's great. How much money are we actually saving though? They wanted us to be able to quantify it. And what's interesting about this is when we first started the company with my co-founders, Dana Van Aken and Bohan Zhang, it was right when the pandemic hit. And everybody was freaking out. Everybody wanted to save money. And so people were asking us, oh, we want to use OtterTune to save money in our database costs. And then as the pandemic kept going on, the tech companies were all flush in cash, right? Interest rates were low. Everybody was at home, using online services. So there was a lot of money. And so we were asked less and less to save money. And it was all about like, hey, can you make my database faster? Can you make my database stable? My database is going to grow. Can OtterTune help me accommodate and grow with me? But in the last year, it turned back. The pendulum swung back the other way. And so there is still sort of core tuning optimizations we want to do for databases, but now we're putting a focus on how to explain to the users, here's the recommendations OtterTune has for your database. Yes, it will make things faster. And here's why we think it will make things faster. But also like, here's how much money you'll save by doing this. And the challenge here is that in some cases, some recommendations won't save you money, but they're like the right thing to do in terms of performance. And we have to sort of figure out, okay, like, how do we prioritize it? Tell the user like, hey, do these recommendations. Even though you're not going to save a lot of money, but we know that's the right thing to do, and sort of explain to them and help them guide them towards doing things that maybe do help with performance, but will eventually get to the more other cost benefits that maybe not immediate.